Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate
Now I want to show you some examples of transformations of rational functions and what it looks like. So I actually have 3 total examples. Let's start with the first one. So f of x equals 1 over x minus 2. Now compare that to your transformational form and ask yourself, what value is being used here? Is it a, is it b, is it c, or is it d? Well, notice in the denominator I have a 2 and x minus 2. This is the c value. This means it's going to be moving right 2 units, because this is the c value and that's a horizontal translation, and you do the opposite of what you see. So even though it looks like it's negative 2, we do the opposite, we move it to the right. So if I move my parent function to the right 2 units, what it's going to do is move my vertical asymptote. So now 2, if I plug 2 into the denominator, notice that's going to give me 0. So my vertical asymptote is x equals 2. Which means my domain is going to be all real numbers except 2. Okay. Now, because I'm only moving my graph left and right, then what happens is the rest of it will still hover above the x and y axis. Now, notice what's going to happen is it's going to create a y-intercept. It still will not have an x-intercept, so my x-intercept is still none. I'm literally taking my graph and just moving it to the right 2 units. My range is going to be unaffected, so I look at my parent function and I realize it's all real numbers except 0. Now let's find that y-intercept. The beauty of finding a y-intercept is you know that x is always 0. So all I have to do is plug in 0 into my function here and get out a number. So let's do some work. Down here. I now have figured out my y-intercept. Last but not least, let's look at end behavior. The end behavior asymptote is referring to how do the ends approaching. So I can see this left piece is approaching 0 from below, and the other piece is approaching 0 from above. So it is a horizontal line, y equals 0. End behavior asymptotes are not always horizontal lines, but in this particular case, and the ones we're going to study, unless you're in the honors class, will always be horizontal. Let's look at example 2. First, let's figure out what transformation happened. Notice I don't have anything in the denominator, so it's not a horizontal translation like it was in the first example. But notice I have a number outside of my fraction. This means it's a vertical translation, and because it's positive, it's going to go up. If this was negative, it would have moved down. So when I take my parent rational function and all I do is move it up 3 units, then what I'm doing is I'm moving that end behavior asymptote. So instead of being the x-axis, it's going to be at 3. And because I'm just taking my parent function and moving it up, it's still going to be asymptotic to the y-axis. So now let's think about this. If it's still asymptotic to the y-axis, that means the domain is all real numbers except 0, just like our parent function. It also means that the y-axis is my vertical asymptote, which is x equals 0. Again, just like my parent function. Now think about it. What has now been modified here? My range, my x-intercept. My y-intercept has not. See, it still will not cross the y-axis, so I'm going to say none. But my range has been messed with. So if we look at our graph here, our sketch, essentially the y-axis will be all y values except 3. Let's find the x-intercept. Now, the x-intercept can be found by setting the function equal to 0. The beauty of every x-intercept is the output is always itself 0. So we're going to take our function, this one's called g of x, and we're going to set it to 0 and solve. So we're going to say 0 equals 1 over x plus 3. Now don't panic. Think of it this way. We're going to use our regular inverse operations, but just because we have a fraction, it just means we're going to use proportions. We do a bunch of that stuff in middle school. So the first thing we want to do is subtract 3. Now, because it's a proportion, think of it over 1, I'm going to cross multiply. So this is going to be negative 3x equals 1. finally, I'm going to divide by -3 on both sides, and I end up with x equals -1/3. Now, what did all this work give us? It gave us our x-intercept. And -1/3 should make sense to us because it is on the negative side. Last but not least, let's look at our end behavior. Our end behavior has been modified. Look at the ends of my graph. They're not going to the x-axis. They're now approaching this 3 value at the ends. So instead of saying y equals 0, I'm going to say y equals 3. Let's look at one more example. In this example, hopefully you notice I now have 2 transformations. I have a number in here, so this is the left and right or horizontal translation, and then I have a number right here, which is my vertical translation. So let's first describe what's happening. Because this is +1, I'm going to be moving to the left 1 unit. Because this is -4, I'm going to be moving down 4 units. So if I move left and right, that's going to move my vertical asymptote. So if I move to the left 1, that means my vertical asymptote is at -1. And if I'm moving my graph then down 4, that means my end behavior is going to be -4. So I'm basically taking my rational function, moving to the left 1 and down 4. So because my a value is positive, there's no reflection happening. I know this upper piece is going to cross something like this, and my bottom piece will be somewhere down here. Let's talk about our characteristics. So what will my domain be? Well, look at my denominator. What's the only number I can't put in my denominator? Well, it's -1, because that would give me a 0. So my domain is all real numbers except -1. I must exclude it. Don't let it go in there, okay? Let's talk range. My range, because this is just a transformation of the parent reciprocal function, can be found by my vertical translation. So it's going to be all the y values except -4. My x-intercept, as I can see, is going to be a negative value. So just like in the last example, in my x-intercept, the output is always 0. So we're going to take our function and set it equal to 0 and solve. I'm going to add 4. Now remember, when you do that, put it over 1, we're going to do cross product here. So 1 times 1 is 1, and this is 4 times the quantity of x plus 1. I'm going to do distributive property. Next, I'm going to subtract 4, and then divide the 4. So all this work just paid off because now what I know is my x-intercept. And notice it's negative, and we anticipated negative. Next, let's look at the y-intercept. Again, I said this before, the best part about y-intercepts is x is always 0, so I can evaluate my function at 0. Let's do my work over here. So I'm going to evaluate my function at 0 because that'll give me my y-intercept. So I'm going to put 0 in for x. And that makes sense because my graph shows me it's going to be the negative side here. Lastly, I need to do my asymptotes. Well, my vertical asymptote I can see is going to be -1. That came from my domain restriction. That came from my translation, left 1 unit. So you're going to say x equals -1. Vertical lines are written as x equals. End behavior asymptotes, well, my ends are approaching that -4 value. That came from my down 4 units transformation. So you're going to write y equals -4. Horizontal lines are written as y equals.